All right, guys, let's continue on. Biological psychology. Part one. This one's disorders. Disorders of the mind. So, three main lines of study: genetics, structural issues, chemical issues. Beginning with mood disorders. Major depressive disorder, also known as clinical depression. So, some of these, what qualifies as major depressive disorder, aka clinical depression: periods of 2 weeks or more of depressed state. Includes getting less pleasure from things that would normally give pleasure. Also anhedonia, which is the loss of pleasure, loss of like satisfaction. Anhedonia. So that was major depressive disorder, also known as clinical depression. It qualified for that as a period of 2 weeks or more of depressed state. Includes getting less pleasure from things that would normally give pleasure. Anhedonia. Another mood disorder is called bipolar disorder. Alternating periods of depression and manic states. Although related in terms of having the depression symptom, they are unique in terms of their biologies. Genetics, major depressive disorder, aka clinical depression. Concordance rate for identical twins is around 50%. So they're thinking there's a 50% chance your identical twin has it, which is similar in biology and similar in genetics, similar in DNA genetics. There's a 50% chance you might also in life become clinically depressed, have major depressive disorder. Adoption studies support a role of genetics. Depression seems to be related to anxiety disorders. So depression seems to be related to anxiety disorders. Families that have depressed members also tend to have higher rates of anxiety disorders. All right, structural issues for major depressive disorder. So there's less activity shown in brain scans with depressed people. Just a little note. There's less activity in the brain with depressed people. Happy moods have been linked to the left frontal lobes. So happy moods have been linked to the left frontal lobes. Depression is correlated to increased right frontal lobe activity and decreased left frontal lobe activity. So happy people's brains, or no, happy moods have been shown to be linked to the left frontal lobes. But depression is correlated to increased right frontal lobe activity and the decrease of the left frontal lobe activity. Left hemisphere damage due to stroke is associated with depression. A correlation may be due to loss of other functions. This has to do with the stroke patients, maybe. So happy moods seem to be in the left hemisphere. Depressed moods seem to be in the right hemisphere. That's structural issues for major depressive disorder. Limbic irregularities. Depressed people have more activity in negative emotion centers, such as the amygdala and the anterior cingulate cortex. Also, they have less activity in brain areas linked to positive emotions. Hence the idea left mood, less activity when they have more activity on the right side, which is for depressed emotions. Obviously, they're going to have less over here, right? So, limbic irregularities. Depressed people have more activity in negative emotion centers. Depressed people have more activity in negative emotion centers, such as the amygdala and the anterior cingulate cortex. Also, they have less activity in brain areas linked to positive emotions, such as the prefrontal cortex. So negative emotions typically happen in the amygdala and the anterior cingulate cortex. Positive emotions typically happen in the prefrontal cortex, where they have less activity. What about chemical issues with MDD, chemical meaning neurotransmitters. We're coming across a new name for these sorts of neurotransmitters. It's the name going to come up right now. So what about chemical issues with major depressive disorder? We know that there are abnormal levels of chemicals. The question is, which are the important ones? Some NTs, some neurotransmitter deficiencies, may be a result of other neurotransmitter deficiencies. So some deficiencies of neurotransmitters over here may be the result of other neurotransmitter deficiencies. But which ones are important? We know that they have abnormal levels of chemicals, those with major depressive disorder. In depressed people, we see elevated growth hormone, thyroid hormone, cortisol, and glucocorticoids. Also lowered monoamines. Monoamines are just most of the neurotransmitters in our bodies. That's what the group is called, monoamines, which means one amino acid. So it means a neurotransmitter that came from one amino acid. That's what a monoamine means. So in depressed people, we see elevated growth hormone, thyroid hormone, cortisol, and glucocorticoids. So cortisol and glucocorticoids are stress hormones. So in depressed people, we see an elevated level of growth hormone, thyroid hormone, and some of these stress hormones like cortisol and glucocorticoids, and also lowered monoamines, which means a neurotransmitter that came from one amino acid. Mono meaning one, amines amino. The biochemistry of depression. Depressed people have HPA axis irregularities. So hypothalamic, pituitary glands, and the adrenal glands. The depressed people have HPA axis irregularities. So the connections between the hypothalamus, the pituitary glands, and the adrenal gland. Sleep irregularities in depressed people. They fall asleep faster. So depressed people fall asleep faster. They enter into REM earlier and spend less time in deep sleep. They fall asleep faster, reach REM quicker, and they spend less time in deep sleep, which is stage 3 and 4, and they awaken frequently. Given how sleep is related to neurotransmitter levels, this makes sense. So there's some theories, right? The monoamine, the neurotransmitter that comes from one amino acid. Theory of depression. The monoamine theory of depression. This is a theory. There is a deficiency in the level of monoamines in depressed people. Drugs that were found to decrease monoamines were found to cause depression. There was a deficiency in the level of monoamines in depressed people. Because drugs that were found to decrease these neurotransmitters that came from one monoamine came from one amino acid were found to cause depression. Because drugs that were found to decrease monoamines were found to cause depression. So they're like, well, this drug kind of took away these monoamines, and what happened? The people became depressed. So they're saying, well, people with depression must have a deficiency in the level of monoamines. Something called Resperine. Not sure what that is. Drugs that were found to increase monoamines tended to help with depression symptoms. But which ones, right? Let's be specific, maybe. What is a monoamine? Most of the neurotransmitters we have discussed are monoamines, but with depression, they are typically thought of as serotonin, norepinephrine, and dopamine. I want to go back over here. So most neurotransmitters we have discussed are monoamines, but with depression, they are typically thought as serotonin, norepinephrine, and dopamine. Go back to my notes. Way back. Way back to the neuron. All right, so the catecholamine family, dopamine, norepinephrine. So what was here? Serotonin, norepinephrine, dopamine. Serotonin has to do with sleep. So anyway, so dopamine, learning and memory and pleasure, addiction, also movement systems. Remember, dopamine, pleasure, learning and memory. These things are sort of like have to be aware and alive. Sort of, they're proactive. Sort of, sort of ways of life, right? Learning and memory and pleasure. And you go with norepinephrine, um, which is from the same catecholamine family as dopamine. So norepinephrine gives a milder, longer lasting increase, both physical and mental. So norepinephrine has to do with attention, focus, and confidence. Also, just like dopamine, which is learning, memory, and pleasure, you have physical and mental, attention, focus, and confidence, right? And then with serotonin, they have trouble sleeping. So you're saying there's serotonin. There's not much of serotonin in our body, but it's spread throughout the whole brain. It's everywhere. It's not clustered. It has to do with sleep, mood, and appetite. So especially serotonin. So serotonin is mood. Serotonin is mood, 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 sleep, appetite. You have dopamine, learning, memory, pleasure. And then with norepinephrine, remember, attention, focus, and confidence. All right, so that's perfect. Very, very attention, focus, and confidence. For norepinephrine, serotonin is mood, sleep, and appetite. Dopamine is learning, memory, and pleasure. So these are all like being affected with people with depression. And now for the drugs, antidepressants, the monoamine theory led to the current medications that we have now. Monoamine oxidase inhibitors, also known as MAOI, MAOIs, MAOI, but like the like plural, MAOIs, MAOIs. Just think about the monoamine oxidase inhibitors. So monoamine theory led to the current medications we have. So monoamine or um, so the monoamine oxidase inhibitors, it stops enzymes from breaking down monoamines. So MAOIs, these monoamine oxidase inhibitors, suppress MAO, which breaks down monoamines. So think about it. Where the synapse is at, where the dendrite meets the where the synapse meet the dendrites, and they have the synaptic gap right here. You have enzymes that break down monoamines, neurotransmitters. They break them down. They're like the garbage can people. Or you have like the recyclers. They reuptake. They send it back up, and it comes back down and reprocesses again to send that neurotransmitter chemical from one neuron to the other. Um, so the I guess an MAO, a monoamine oxidase. So the monoamine theory led to current medications. So ASE is an enzyme. I'm gonna get this. I want to get this properly here. So ASE equals an enzyme. So a monoamine oxidase. So a monoamine oxidase is an enzyme. So it's a mono. It breaks down monoamines. But the inhibitor, the drug, the MAOI, is an inhibitor of the enzyme monoamine oxidase. So the MAOI inhibitor suppresses the MAO. So it stopped the enzyme from breaking it down. So that way they felt like, well, this monoamine this enzyme is just breaking down these neurotransmitters. So how about we give we create this drug that inhibits this enzyme process, stops it, so that way the neurotransmitters can make better connections and they won't be depressed, right? There'll be more serotonin in the system. There'll be more like these enzymes are just breaking it down too much because they were thinking this theory was that they had a serotonin deficiency, their mood, um, norepinephrine, their confidence and focus and attention, maybe with their pleasure system, with the dopamine system. So let's give them an MAO inhibitor to stop the enzymes from doing their job. So the MAOIs suppress the MAOs, which break down monoamines. There was bad side effects and dangerous dietary restrictions. Something called the tricyclic antidepressants. Tricyclic antidepressants contains a three-ring carbon chain, thus the name tricyclic. So a tricyclic antidepressant, it contains a three-ring carbon chain. So what that does, it no longer worrying about the enzyme, it inhibits the reuptake of serotonin. So it stops the reuptake of serotonin and norepinephrine. Remember, serotonin had to do with sleep, mood, and appetite. And norepinephrine had to do with attention, focus, and confidence. So it inhibited the reuptake of serotonin and norepinephrine. And it also acts on histamine and acetylcholine. Leads to side effects, led to the desire to develop drugs that worked in very targeted ways. So it led to the desire for scientists to develop drugs that worked in very targeted ways, very specific ways, not so much it's going to affect more than what it needs to, more targeted ways, more specific. So it says it also acts on histamine and acetylcholine. This is a tricyclic antidepressant, inhibits the reuptake of serotonin and norepinephrine. Um, but that also led to side effects. So since it acts on histamine, um, an increase of histamine leads to like a stuffy nose, a feeling of sneezing and pressure. For example, Benadryl acts as an antihistamine, so it's kind of like this sort of allergic reaction sort of thing. Leads to like a cold symptoms, I guess. So the monoamine oxidase inhibitor, it suppressed the MAO from it suppressed the enzyme from breaking down the monoamines, but it led to side effects. And the tricyclic antidepressants targeted more in the reuptake process, thinking it was going to allow more norepinephrine and serotonin. But that also had some. It also acted on the histamines and acetylcholine. That led to side effects, which led to research and development for drugs that worked in very targeted ways. All right, guys, so now to what we know as SSRIs. So selective serotonin reuptake inhibitors. That's what SSRIs stand for. Selective serotonin reuptake inhibitors. Inhibits the reuptake of serotonin. It stops the reuptake process of serotonin. Remember the recycling period and the synaptic gap from the axon terminals to the synapses to the dendrites, right? Let's go back over here. Take that out. Back to our cellular diagrams. it out. Anyway, so these SSRIs inhibit the reuptake of serotonin. Some of these drugs are called Prozac, Zoloft, Lexapro. So the response rate is no better than for tricyclics, but fewer side effects and less health concerns. So the response rate is no better than for tricyclics, but fewer side effects and less health concerns. Other medications are being researched. Some medications that deal with serotonin and norepinephrine, which are so there's serotonin, norepinephrine reuptake inhibitors, SNRIs. Um, so targeting serotonin and norepinephrine. There's another one that just targets norepinephrine dopamine reuptake inhibitors, so NDRIs, norepinephrine dopamine reuptake inhibitors. But the ones that seem to be working the most are the selective serotonin reuptake inhibitors. Issues with the monoamine theory. Issues with the monoamine theory. It minimizes the contribution of other neurotransmitters, so such as glutamate and GABA. So it minimizes the contribution of other neurotransmitters. So it kind of ignores the other ones that seem to be important. Glutamate and GABA are the two most common neurotransmitters in the central nervous system. One would think they might be involved. Drugs that increase the amount of monoamines typically take weeks to help improve symptoms. They think why, if reuptake increases monoamines immediately, led to a new focus on the receptors. So no longer thinking just simply these neurotransmitters, but they're thinking about what about the receptors. It led to a new theory, receptor sensitivity theory. It is long-term changes at the receptors that help depressed patients improve. Something about a down regulation of these receptors. So receptor sensitivity theory, it is long-term changes at the receptors that help depressed patients improve. I need it. So down regulation. So either it's too much, has been a too long process of not having enough serotonin that these receptors just said, oh, I'm just standing here. They did a down regulation. They just pulled back from the dendrite area or the synaptic gap because there wasn't enough, or maybe there was too much where it decided to back up. Not really sure, but it's called down regulation. So bipolar disorder. Now, that was a lot on depression, right? So bipolar disorder. Genetics absolutely play a role in bipolar disorder. Concordance rates seem to be between 70 and 90% have been reported. I don't know. I think this sounds kind of odd. It's a high number. I don't like these sorts of guarantees. I think, well, this is specifically just like in science. This is science. This is not like this is not preaching or trying to motivate you to do better and believe in yourself. No, they're saying there's a genetic component here. There's a genetic proof and genetic evidence to say that there's a concordance rate of nearly 70 to 90% have been reported. That if your mom was bipolar, there's a chance you might be bipolar. I don't know. I don't really like that idea. I think that has to do more environment, has to do with more almost spirituality, where it's like, well, yeah, if you don't fucking something your fucking great great grandfather did might set the stage for further generations, you know. So what comes before the chicken or the egg? So brain structures of bipolarism, I guess. Lower amount of gray matter. So brains with bipolar disorder have a lower amount of the gray matter in your brain that deals with processing. White matter has to do with sending information. Gray matter has to do with processing information. So some of these structures are the prefrontal cortex and the limbic structures. Let's talk about the basal ganglia function abnormality. So people with bipolar have basal ganglia function abnormalities. So basal ganglia had a lot to do with procedural movements. So remember, the striatum is there and helps with executive functions. The striatum is there and helps to deal with executive functions. Certain chemicals of bipolar disorder. It seems a little side note. Lithium, the drug lithium, seems to help bipolar disorder. Originally, it was assumed to be monoamine related, so neurotransmitter related, since depression is a component of bipolar disorder. If depression equals too little monoamine, mania could be too much monoamine, like having manic depressive disorders. So if depression is having too little of these important neurotransmitters, these important monoamines, mania could be the opposite, too much monoamines. Now, it appears that it might be an imbalance. Too little serotonin with too much norepinephrine. So that's pretty much it for bipolar disorder. So schizophrenia symptoms. With schizophrenia, there are positive symptoms. We're not thinking positive as happy-go-lucky positive. No, something that's making an addition, an add to it. A positive meaning it's going up. Whether negative or positive is getting more negative or getting more positive. Okay, so schizophrenia symptoms, positive emotions such as delusions, hallucinations, disorganized speech, disorganized behavior. So positive symptoms, delusions. A delusion is a belief. So more delusions, more hallucinations, an increase of disorganized. Because if it's a positive symptom, it's seen, it's shown. So delusions, hallucinations, uh, disorganized speech, disorganized behavior, and some negative emotions, some drawbacks. You have social withdrawal, and mood disturbance. An example of a mood disturbance is sort of a flat affect. There's, so to speak, with a voice that's lacking any sort of personality. Kind of seems like they're just mellowed out, or I don't know, just lacks personality. They have a flat affect. Schizophrenia has different outcomes. So sort of, they don't have all of these symptoms we just mentioned, whether they're positive, like delusions, hallucinations, disorganized speech, disorganized behavior, or sort of this social withdrawal or a mood disturbance. They don't have all of these symptoms. Um, it seems that the men have more of these positive symptoms, such as delusions, hallucinations, disorganized speech, disorganized behavior, and women tend to have more of the negative symptoms, such as social withdrawal and mood disturbance. And males are diagnosed younger than women. Um, some of these genetic proponents or components of schizophrenia. Another heritability index, 40 to 60%. For fraternal twins, it drops from 10 to 20% concordance rate. Children of schizophrenic parent, they have a 14 to 17% chance of having schizophrenia. Some structural issues, gray matter loss, remember processing of information, tissue loss, frontal cortex, anterior temporal lobes, and the hypothalamus are all smaller. So the frontal cortex is smaller, the anterior temporal lobes are smaller, and the hypothalamus are smaller. Some more structural issues. Schizophrenia brains seem to be smaller but have bigger holes, um, bigger ventricles in the brain. So, yeah, they have enlarged ventricles and a shrunken hippocampus. Structural issues continued. Hippocampus cell bodies in a control participant are arranged neatly. But hippocampus cell bodies in a participant diagnosed with schizophrenia appear disorganized. So, hippocampus cell bodies are neatly arranged in a normal person. Hippocampus cell bodies in a person with schizophrenia appear to be disorganized. Some of these hallucinations, activity pattern for a hallucination lacks the activity and the basic auditory structures. So activity pattern for a hallucination lacks the activity and the basic auditory structures. Some chemical issues. Seems to be all about dopamine. Dopamine hypothesis. An overabundance of dopamine and leads to overactivity. So too much dopamine leads to overactivity. May be the basis for hallucinations and delusions. All right, so can we stop there? Maybe we'll keep going. So evaluating the dopamine hypothesis. There's evidence in favor of this hypothesis. Drugs that increase dopamine activity in schizophrenics increase symptoms. Drugs like cocaine and meth, they seem to increase dopamine activity in schizophrenics and increase the symptoms. So it's sort of these drugs that increase dopamine seem to increase, the symptoms in schizophrenics. Drugs that block dopamine receptors lessen the symptoms. The evidence against this sort of hypothesis, the dopamine hypothesis: 25% of patients don't respond to dopamine antagonist blockers. About one out of every four person, they don't respond to dopamine antagonists. I mean, these anti-dopamine drugs that should slow down the symptoms, right? I don't know. So new generations of antipsychotic meds impact other neurotransmitters beyond just dopamine. Drugs change dopamine activity immediately, but patients may not improve for weeks. Prolactin levels in schizophrenics are normal. So milk production levels in schizophrenics are normal. Dopamine inhibits prolactin production. PCP leads to schizophrenia-like symptoms by blocking the NMDA glutamate receptor. The reward pathway. I don't know. That has to do with some other thing I'm about to read. So PCP leads to schizophrenia-like symptoms by blocking the NMDA glutamate receptor. So they're saying it's not just dopamine. It's not all dopamine, right? It's not all dopamine. There's other things. Um, Adjustments to chemical theories. A revision of the dopamine hypothesis. Increased dopamine activity in the mesolimbic areas, the reward pathways, and decreased dopamine activity in the prefrontal cortex. So increased dopamine activity in the mesolimbic reward pathway and decreased dopamine activity in the prefrontal cortex. I don't know if that's important for the test, but glutamate hypothesis. Perhaps levels of glutamate are responsible. Remember, glutamate was the main excitatory neurotransmitter. So perhaps levels of glutamate are responsible, I guess, for um, schizophrenia. May explain the negative symptoms better than dopamine. May explain the negative symptoms. Remember, the negative symptoms had to do with social withdrawal and mood disturbance. So they're saying maybe glutamate seems to be glutamate. The levels of glutamate seem to be responsible, and the glutamate reaction or the glutamate hypothesis may explain the negative symptoms better than dopamine. So a decrease in glutamate may cause these social withdrawal and these mood disturbances. I think that glutamate might also play a bigger role in schizophrenia than just dopamine, right? So it seems like things are still studying. They're still trying to figure out that it's not sort of certain yet. So I don't know. All right. Well, so where we left off.